Hello, everybody. I can't see you very well, which may be a good thing, but after my esteemed colleague from Siemens, it is obviously GE's turn, and I think in some ways he set the stage for what we're about to talk about. So I think two things he talked about, I kind of want to pick up on that. One thing he talked about was the motive. Why are we doing this? Why is GE investing so much in what we call the industrial internet? And then he talked about the central data platform, and that's something I own for GE, and we call it the industrial data lake. So I think those are the two themes we're going to kind of focus on as we walk the next 20 minutes. So the first thing is what is happening in reality, right? And this is something important to understand is what we talk about is the physical world of machines or equipment or assets, as GE refers to them out in the field. They're starting to generate a lot of data, and most of them are equipped with sensors. Sensors are sending out streaming data. And we've been capturing this data in either batch form or even sometimes real time. And we've been doing some analytics. But I think slowly with the increase in computing power and storage getting cheaper, what is happening is the two worlds are colliding. The type of analytics we are able to do on different data types, and how soon can we do it from the point of origin of the data to where we can feed the results back to the machines or the human operators operating those machines or assets. That's getting smaller and smaller. So we talk about the physical and the analytic worlds converging. Okay, and a quick background or a little deep dive down into what GE is and what are the industries we play in. We play in aviation, energy management, healthcare, lighting, oil and gas, power and water, and transportation. And when we refer to big iron, we're not referring to routers in a data center. For us, the big irons are the big machines out there, whether it be a rail car, whether it be an aircraft engine, or whether it be a health imaging type mechanism, right? That's generating a lot of patient data, a lot of scanning data, right? And the idea is that, again, these machines are generating data. Let's capture that data, let's analyze that data, and let's make us more effective at operating those assets in the field so there are less downtime and we can bring customers the value, right? So really, one way to do that is there's a lot of data coming in at velocity. There's different data types that are coming in. So we've been kind of zeroed in on this concept of, again, what the previous speaker referred to is the central data platform, which is really our big data lake platform. And it's a collection of technologies. It's not a single technology. It's a collection of technologies that's able to deal with different data types and how to store it. Okay, we are headquartered out of the Bay Area in San Ramon. If you're familiar with that area, it's across the bay from San Francisco. We have roughly currently about 1,200 employees over there, and GE over the years, the last 3 years, I believe, has made an investment of $1 billion to kind of get this thing going, right? Which is the whole platform, the people, the resources, the skill set, and a lot of plumbing or networking work that we have to do to be able to flow these data in from the assets. Okay. So what I wanted to talk about is we talked about the motive. Why do we want to do this? And really, I want to take the next 3 slides to talk about some of the customer outcomes that are either projected or we are already starting to see some return on some of the initial investments in data and analytics that we've made. So let's talk about our transportation business. You see the rail car on the left. And what we show on the right are really 4 things that we're trying to get a better understanding around. And then the way to get that understanding is to look at data in ways that we've never really looked at before. Collect data that we've traditionally not collected before. So one example, one project that my team's currently working on that kind of popped up on our plate a couple of weeks ago was that we are actually starting to take pictures of railway tracks to see if vegetation is growing on it, right? But even similar simple things like that and our ability to take those pictures, gather the data, and do the analytics on top of it is things that we've never been able to do before, right? At scale, which is important, and near real time, so we can take preventive action. So here's a snapshot of some of the problems specific to rail cars or assets that we are looking at, and then some of the projected savings, now and in the future. Okay, going over to our oil and gas business, so the familiar sight of an oil rig, and some of the similar concepts, how's the asset holding up? What's the general state of health of the asset? Like inspection, is there a better way to do inspection rather than somebody climbing a 100-foot ladder on an oil rig, which is not always the safest thing to do, right? Can we take pictures, right? And then how do we again analyze? So here's again some use cases, some examples we are working on is, what is the lost productivity if a component of the oil rig goes down, slower deliveries, how are our pipelines optimized for delivery coming out of the oil rigs, either into a refinery or to our end customers, right? How do we better manage workforce downtime? So if you look at this, it's not just about machines, but it's also about the people who are working on the machines, and how do we take a holistic view at data across the space. And this is where, when we talk about IoT, this is where the industrial internet is converging with traditional data sources that we've handled within the enterprise, like either a ERP data or a supply chain data, and how to bring all that data together to kind of understand the overall health of an asset and what we need to do to, again, get things right. Aviation's a classic example. This aviation was where we really started our big data journey about 2 years ago. And it's really not only about our aircrafts taking off on time, are they delayed, and what cost or impact does that have to us and to our customers. And then really the other thing is looking at flight data, analyzing not only and collecting that data, not only for historical analysis, right, so we can develop smarter algorithms, but the idea is that once an aircraft is in flight and the aircraft engine is sending out data with the sensors that's installed on that engine, can we take corrective action? Can we predict what's going to happen as the flight is in motion? So again, the worlds are converging. We are able to do analytics quicker and potentially flow the analytics insight back to the aircraft or the operator of the aircraft in case there's any corrective action that needs to be taken. Okay? So this is a slide we talk about why are we doing this. I think if you start looking at some of the dollar numbers, these are all projections. There's immense value in this. Not only are we able to keep our assets in the field longer, operating efficiently, which is a direct value to our customers, but also, it kind of allows us to be more efficient as to how we service these assets. So a lot of these big data efforts are really coming out, not so much of our manufacturing space, but really of our service. Like once we put an asset and make it operational in the field, how do we make service more palatable for our customers? How do we make sure that first time we are right, the way we diagnose the problem, the fixes that we put in place, right? And then we strongly believe that big data and analytics has a big role to play in that scenario. Okay, so that was the motive part. Now let's talk a little bit about the data platform, because this is the piece I really own. I provide a platform to our data scientists, to our customers, where they can not only flow the data in, but do the analytics. So this is really kind of a snapshot of how we look at the data lake. So the data lake is really here on the right, which is kind of the circle, but the idea is that the data lake, again, should have the technology and the capability to flow in data from our different assets and internal sources, be able to store it, harmonize and stitch the data, which again the previous speaker referenced, and then be able to drive analytics or even trends out of that combined data set, and how does that collectively make us better in managing our assets across the space. Okay, and here are some numbers around like one data or one flight usually generates about 1 terabyte of time series data, right? 9 million data points per hour for each locomotive that's running on the track, right? Again, how do we grab that data? How do we make meaning out of data? How do we put context around that data? And then how do we drive analytics, okay? So, you know, why did we start the big data journey? Because I keep getting this question is, well, how is this different from BI? And you know, the BI technologies serve a specific purpose, but they are not really scalable, or they cannot really deal with the different data types that we are dealing with in the real world when we start talking about the industrial data net. So, you know, they're simply not scaled to do, you know, algorithms, machine learning algorithms at scale, or, you know, with the adequate number of iterations on a document that's been scanned. That is not what an Oracle or a DB2 was set up to do, right? So it's an evolution. It's not that the data stored in those traditional SQL structures we cannot use in our analytics, but those traditional platforms are not the platforms for analytics, okay? And then if we try to make them be a platform of analytics, they often tend to be very expensive, because you've all heard about vertical scaling versus horizontal scaling, right? Most database, commercial databases or analytics platform traditionally have scaled vertically, but what we're looking when we talk about big data, when we talk about Hadoop, it's all about horizontal scaling and being able to add nodes on the fly. And then it's too rigid, because they were set up to serve a very, very specific purpose, and they do it very well. Talk about transactions, talk about OLTP databases, they do that very well. But really, I think what we're looking for is in the platform or the data lake is the flexibility again to be able to deal with various types of data and our ability to combine the data and then run analytics on it, okay? I think I've already covered this, so I don't really want to spend too much time about, but I think most of you, you know, as IT practitioners are familiar with this, is we have a problem in the sense we have a legacy problem with how we've traditionally handled data, stored data, and what we've done with it. And this is a problem that we have to solve, most of us. I think there's the industrial piece, and then there's the enterprise piece. This is in some ways very representative of the enterprise data, right? If you buy a certain ERP, you know, whether it be SAP or it be Oracle, there is a tendency to basically go with a BI or a data management technology that's very closely aligned to one of those vendors, right? But what it does over time is it starts creating silos with their own data models and with their own specific use cases and with their own customizations, because it's fulfilling a very specific business need or an operational need. The challenge is now to take what you have and kind of morph into the next evolution of the architecture such that this data all of a sudden becomes free or open to newer interpretations and to a wider set of users, right? So again, I think whenever somebody asks me is how is this different from BI, I say, you know, BI was at looking back, whereas what we are trying to really do in the new scheme of things with the new platforms, with the analytics algorithms, is to really look into the future and be able to predict, okay? Traditional BI tools like a Cognos or business objects, that was not their forte. That was not what they were built for. So it is not fair to them to try to make them do that. It's really how do we step forward into the next evolution of analytics, which is all around predictive and prescriptive, right? So what I'll try to do is kind of now bring back the concept of the industrial data lake and how it kind of is an evolution from the slide that we showed before, which is really the industrial data lake is not a system of transaction. It is really a way to collect the data and consolidate it on a single platform. And again, the caveat is the single platform doesn't mean a single technology. It's a collection of technologies. There are still the usual suspects, like there are SQL databases, there's Hadoop, there's NoSQL, and then there's all kinds of flavors in between, right? And we have to make the decision as to what makes sense given the use case or the problem we're trying to solve, right? And how we're going to get the data or the analytics results set back to the user, or ideally to the machine, so that it can self-correct itself. That's the holy grail of the industrial internet. And I think, again, the previous speaker referenced it, is machines talking to each other, right? It's our analytics to be able to influence how the machine is operating. So does a turbine need to slow down or speed up? Does a rail car needs to slow down or speed up? This is really what ultimately, in the long run, not tomorrow, is what we're trying to do. But to get there, what we have to do is we have to centralize the data on a central data platform. We have to harmonize the data. We have to stitch the data before we can even start driving insights out of that data. Okay? And honestly, this is my last slide, so I might be able to give you guys some time back. What we did is we took somewhat of a, well, as we started working on use cases across all these industries, like whether it be, you know, our transportation business or oil and gas business, what we tried to do is come up with what we call repeating patterns, patterns of data management, data usage, and analytics that we were starting to see over and over again. And what we said was that these are the 4 patterns that keep popping out at us as we deal with use cases. And these patterns are not mutually exclusive. Like, you can start with pattern 1, and as your analytics get more sophisticated, as you start pulling in more data types, you could go on to the next pattern, which is advanced analytics, right? And then you have to figure out a way to search and do API-like calls to the data and the analytics result set. So, and then finally is the holy grail that I just kind of walked through you guys a little while ago, is the real-time analytics. That is our ability to grab signals coming off our sensors on our assets, the ability to process it in real time or near real time, slap some analytics on it, and then send it back to whoever's consuming it, whether it's the human operator operating the asset, or it's the machines themselves, if they're intelligent enough to pick up a signal coming back from our data lake, from our cloud, telling it what to do, okay? And then the other thing is, these patterns, what they allow us to do is, in some ways, they guide us to the right technology to be used. Because again, the data lake is a collection of technologies, and we want to make sure that the right technology is being applied to the right use case, right? So if it's real-time analytics, we would question the relevance of Hadoop as a platform to run real-time analytics on, right? So when we talk about big data, when we talk about data lakes, again, the message I keep sending is it's different kinds of data stores depending on the use cases we're running. So let's be very clear, and we fully understand that you can start with pattern 1, and over time, as your analytics get more sophisticated, as you're able to capture the data in more real time, you will graduate to 4. But getting from 1 to 4, you will be undergoing, or you will be picking different technologies to fulfill your mission here, which is, again, to make our assets in the field perform better. So that's all I had. Hopefully that was adequate. I'm done. Thank you. Thanks. It's a pleasure.